Hi everyone, welcome back. So this time we're going to be doing our group problem. So grab a friend, grab a road duck, grab a stuffed animal. I choose a sloth in my opinion, but sloths are awesome. And so what's our problem? Well, this automobile has a mass of 2,000 kilograms and has a coefficient of friction of 0.3. I'm going to find the smallest force F to cause this car to move if the front wheels can roll and the back wheels are locked. Okay. A lot going on there. You're like, ooh, front wheels, back wheels, that's interesting. Yes, that'll make things a bit harder. So what's your plan? Let's get a plan. Draw free body diagram, determine unknowns, and solve your equations, equilibrium, and friction equations. You're like, but this is the same plan as always, and it always works. Algebra is hard, but that's really all that comes into this. So go forth. You can do this. I have complete confidence in all of you. So I'm going to count to 3, and then you're going to pause. You're going to go and do this. You're going to come back. So 1, 2, 3. Okay, you paused, you came back, or maybe you didn't. I'm believing you did, but maybe you didn't. I won't judge you if you did. Maybe I'll judge you slightly. But let's check this out and see how we solve it. So the first step is going to be free body diagram. Okay? We have a free body diagram right here. We know we're going to have a normal force at both of the wheels, only a frictional force at the back wheel. We also know that friction is going to be pointing to the right, well, to my right, your left, I guess, because the force is going in this direction. I've got to be more careful with my thumbs because it's reversed when I look at the video. Okay, we know what the weight of the car is, and it's applied at the center of gravity, which luckily is given to us. We don't have to calculate that somehow. So there are 4 unknowns. 4 unknowns. And we have some forces in the x, some forces in the y, some in the moments, and a frictional equation. Oh, well, maybe we can solve. But that frictional equation only works if we're at the max friction possible. So you got to think about that. Are we going to be at the max friction possible? Well, let's not worry about that too much right now. Let's just go ahead and plug in everything into our equations and see if we can solve. So some of the forces in the x, we have our frictional force B, and that's resisting the x component of our force F. Pretty simple. So the forces in the y, we have both of our normal forces, which are resisting the weight. And we also have the y component of this force helping out. And then so in the moments, which we're going to take about point A, and so we have our force times cosine of 30. We actually have 2 components from our force, because if you look at this, both components will cause a moment around A because there is both an x and a y distance to where that F is applied. We also have the normal force at B, which causes a rotation. And we have our weight, which also causes a rotation. And finally, that last equation. Okay, can I use the max frictional force equation? Can I do it? Well, my first question to you is this car going to tip based on how it's set up? If you pull on this, is this magically going to somehow flop over? As you probably can guess, no, it's not going to tip. It will slip. These front wheels can roll, the back wheels will slide at some point. And that can hopefully help us out. So if we assume that the real wheels are on the verge of slip, we get this right here, 0.3 times the normal force at B. And hopefully that is the correct answer. So we apply all of these, and we get this answer right here. Okay, so we get our force, 2,362 newtons, normal force at both the wheels, and our force at B. Oh, and that was it. Now, I'll be super honest with you. This is a lot of algebra right here. Is there an easy way to do this? There really isn't all that nice of a way to do it. It's 4 equations. They're all fairly well connected. And so it's going to be a bit of a pain to do this. But you can do it. I strongly suggest, though, that you try your best to learn how to use your calculator to assist you in this. Because that calculator is going to be extremely important to doing this. You know what, I might even load up a video, at least I'll try to, because it's weird to do a calculator on a computer. But if I can get a TI-83 plug into the computer, I'll take a video of it to show you how to use it to solve equations. And one last little detail that I kind of glossed over, I want to make sure you notice here, is I said cosine of 30 right here to get the x component. That is because if I draw my x component for this force, and then the y component, this is the adjacent side. Adjacent over hypotenuse is cosine. And for the y component, the opposite side over here is the y component. So opposite over hypotenuse is sine. Just a little detail to make sure you know where that's coming from. Okay, so with that in mind, I hope this helps you. Honestly, getting the equation set up is probably the easiest part in most of these problems. It's then solving them that can make it a lot more difficult. So practice with your calculator, practice with just algebra in general, writing down the equations, and you'll get there, I promise. Hope you have a wonderful day. I'll see all of you later. Bye-bye.